Hello friends, welcome back. In previous videos, we have already done with the synthesis of three target molecules that are the first one is S-propanediol, then R and S epichlorohydrin and the synthesis for L-alanine. In this video, we are going to start the next target molecule that is the minus pentenomycin. The pentenomycin, it is one of the important natural product as a medicinal point of view as it is used as an antibiotic. So let's start with the synthesis for the minus pentenomycin. So here you can see the structure for the minus pentenomycin is like this. Here the 5-member cyclic compound along with the 3 hydroxy groups and the alkene. Okay, so it is one of the important natural product. Therefore, there is a need to synthesis this molecule. So before start the synthesis, let revise some concept that are the target molecule. So what is the target molecule? The molecule whose synthesis being planned, it is called the target molecule. Then the retrosynthesis. In every synthesis, before start the synthesis, we write the retrosynthesis for our target molecule. So the retrosynthesis means an imaginary but logical reverse chemical reaction which helps us to reach the reactant starting from the target molecule. This is called the retrosynthesis. And what is the retrosynthetic analysis? The process of breaking down the target molecule into a convenient starting material using the disconnection and FGI. This is called the retrosynthetic analysis. So in previous videos we have already learned what are the target molecule, retrosynthesis and the retrosynthetic analysis. In every retrosynthetic analysis we do the disconnection and the FGI. These are the important term in the retrosynthetic analysis. Okay, so here our target molecule, this is the minus pentenomycin. It is an important natural product obtained from the D-glucose. So the starting material for this minus pentenomycin is the D-glucose. This is the 5-member cyclic compound. The 3 hydroxy groups similar to the carbohydrate. So see the retrosynthesis. Here our target molecule, that is the pentenomycin. In first step we do the first FGI and we convert the molecule into this. So if you can look at this target molecule, here it is a alpha beta unsaturated compound. So the alpha beta unsaturated compound is come from the aldol condensation. Okay, intramolecular aldol condensation. So here we write the FGI and here we got this OH group. Okay, and after the breaking of this OH bond, here it is a formation of this aldehyde group and here there is a negative charge formation and we got the molecule is like this. So you have to know the aldol condensation. Here if you look, there is a alpha beta unsaturated and we got the alpha beta unsaturated molecule in the aldol condensation. Therefore we write the first FGI as like this and here we get the one ketone and one aldehyde molecule. In the next FGI, here you can see there is a 5-member cyclic compound and the one atom is the oxygen. And here it is a OMe is present. This is the second FGI. In third FGI, here we write the OMe as the OR. Means here it is a replace the OMe with this OR group. In the next FGI, there is a formation of this diol molecule. Okay, so here it is a come the diol. Then after in the next FGI, there is a D-glucose formation. So our starting material is a D-glucose. The D-glucose we can write as like this. In the next step, the D-glucose is converted into this 5-membered compound, that is the D-arabinose. Okay. In our target molecule, there is a 5-member ring. Therefore, we convert the D-glucose into this D-arabinose molecule. So our starting material or a chiral precursor in the synthesis of minus pentenomycin, that is the D-arabinose. Okay, so you can start the synthesis from either the D-glucose or the D-arabinose. So our starting material is the D-arabinose. So let's start the synthesis. Here are the steps for the synthesis of pentenomycin. The reagents. Here it is a D-arabinose. The first step, there is a protection. Okay, so here there are two types of diol molecule. This is the one first diol and this is the second diol. And if we react this D-arabinose with this acetone in presence of acid, we got the protected diols. Okay, and we got this as a product. In the first step, there is a protection of two diols and we got this as a product. This OH is remains as it is. In next step, there is a CrO3 in presence of acetone. This is the oxidizing reagent. Therefore, after the oxidation of this molecule, here it is a OH group. It can be oxidized and there is a formation of this carbonyl. In next step, we use the nitromethane in presence of base. Okay, so as the nitro group is electron withdrawing, it is attached to this CH3. Therefore, this hydrogen is acidic, and if we use in presence of base, then this base can easily abstract the proton. Okay, and here it is a formation of CH2 negative. Therefore, it can easily attack over this carbonyl group. Okay, there is a formation of CH2 negative. Okay, and here it is attacked over this electrophilic center and there is an opening of this O negative. Then after the hydrolysis, here the formation of this OH. So this here it is a OH group. Okay, and this is the CH2NO2. This is come from the nitromethane in presence of base. In next step, we use the alkaline KMNO4. So the alkaline KMNO4 is the oxidizing reagent. It can be oxidizes this NO2 into the aldehydic group. So after the reacting alkaline KMNO4 with this molecule, the nitro group is converted into this aldehydic group. This CH2 NO2 is converted into this aldehydic group. Then after, here it is a reduction of this aldehydic molecule by using the LiAlH4 or the NaBH4. Okay, either LAH or the NaBH4 we can use for the reduction of this aldehydic group. Okay, then here we use the NaI molecule. So this hydride can be abstract this hydrogen and there is a formation of O negative. In next step, we use the BNBR, that is the benzyl bromide. This form negative charge can attack over this benzyl and there is a removal of this chloride molecule. And we got here the OBN. Okay, that means there is a protection of this hydroxy group by means of OBN in presence of NaH. In next step, there is a hydrolysis. The hydrolysis for the selective deprotection of this diol can be done with the hydrolysis and we got this as a product. In next step, there is a NaIO4. It is used for the cleavage of diol to aldehyde. Here we can deprotect this diol, okay, by means of the hydrolysis. Here there is a deprotection and we got this diol. And then after we use the NaIO4, then after by using this oxidizing reagent, here it is the cleavage of this diol to the aldehyde and there is a formation of aldehydic group. Okay, Then after the formation of this aldehyde molecule, we reduced by means of sodium borohydride, and here we got the primary alcohol. Okay. In next step, after the formation of this alcohol, we use the TSCl in presence of pyridine. So here it is a protection of this hydroxy group by means of this TSCl, and we got here it is a OTS molecule. Then by using the 2,2-dimethoxypropane, this is the protecting group, and we got here it is a protection of, if we use this 2,2-dimethoxypropane, there is here it is a D protection, and these two diol can be protected by using in this one step, and we got this protected diol. And in next step, the base is used, the tertiary butoxide can extract this proton, and here it is a removal of this OTS molecule, and there is a formation of double bond as like this. Then after here it is a H plus, and here after by using the acidic medium, there is a ring opening, and we got the product as like this. Here it is a ketone, and there is a one aldehyde molecule. When we use the base, here it is abstraction of this alpha proton, and then after there is a intramolecular aldol condensation reaction, and we got this as a product, this protected diol, and this OBN is remains same. Here after the abstraction of this proton, there is a formation of negative charge, and this negative charge can attack over this molecule, and there is a formation of this 5-member alpha beta unsaturated compound, that is the product of intramolecular aldol condensation. Then by using the H2SO4 in acetic anhydride, there is OBN is converted into this OAC group. Then we use the lipase deacetylation, then this OAC is converted to this OH moiety. So this is our final product, which is the minus pentenomycin. I hope you understand. Thank you for watching.